Hey, welcome to your log review packet from Algebra 2. I want to make sure that you can still do all these skills. First section, rewrite each equation, which are written as logs, but I want you to write them as exponential form. First step is to go around the block, starting with the base. So this is the base. The 0 over here is the exponent. And this position, which is your argument, is what it equals. So 11 to the 0 power equals 1. So you want to write 1 through 9. This one would be 1/19 to the second power equals 1 over 361, just to give you a heads up on number 4. Next section, 9 through 16, they are in exponential form, and you need to write them in log form. Again, going around the block, as I like to say, starting with the base. So you'll do log, the base is y, of 158 you write next, equals x. Logs always equal the exponent. So it's the y is first, the 158 is second, and the x is last. Please make sure your y is small and written as a subscript. So that is the second section, 9 through 16. Next sections are ones you can do with your green frequently used powers sheet that you have. These are ones I expect you to be able to do without a calculator. And to be quite honest, I like to think of the problem in exponential form when I do it. For example, when I look at this problem, I don't think log base 6 of 216. I think 6 to what power gives me 216, and that power would be 3. One that I want to make sure you're okay on is number 26, because you want to think 16 to what power gives me 4. And I know if you take the square root of 16, you get 4. And the 1/2 power, this is square root. Square root would be first power, second root. That means the same thing. So this guy right here is 1/2. I also want to show one more, 27. If you were to evaluate this, you want to think 2 to what power gives you 1 over 32. Well, I know 2 to the 5th power gives me 32. But since this is on the bottom, my exponent would be negative. So 2 to the negative 5th power would be 1 over 32. Just a quick review, if you had 2 to the negative 5th, that's the same as 1 over 2 to the positive 5th. And 2 to the 5th, 2 times 2 times 2 times 2 times 2 is 32. So you just write the exponent on your sheet, because that's all the log equals or is. Next section is expanding. If you have a fraction or multiplication in the argument position, you can expand it and write it as more than one log. I like to say a fraction means subtraction, to help me remember that this is equal to the log of 5 minus the log of 3. If this is multiplication, it's the log of 5 plus the log of 8. Now, if I look at this one right here, I do not see multiplication there. I don't see a fraction. So one thing that you may remember is this is the same as log of 12 to the 1/3 power. First power, third root. So I can write it like this. So I can fly this guy to the front if I want and write it as 1/3 log of 12 or log of 12 divided by 3. So the next section we're going to do would be section from 48 on. In this section it says condense each expression to a single log. Well, this one right here is a good one to go over. This has subtraction, so that means subtraction means a fraction, so that's the log of 3/8. So if you have subtraction, you can take the arguments and write it as a fraction. Okay, so if I look here at this one or this one, they are already a single log. So something you could do to fix them is write this maybe as 1/3 log of 8, because dividing by 3, that's a 1/3 in front. If there's a number in front, you can fly it up. Log of 8 to the 1/3 power. 1/3 power is power over root, so it is log of the cube root of 8, which I happen to know is 2, because 2 times 2 times 2 would give me 8. So this right here, best answer is that guy right there. It is already 1 log. Next section, or same section, but working with maybe ones that have pluses that I can write as a single log. If I look here at 57, if I want to write it as a single log, I want to make sure that I have all the arguments correct. So this is log base 7 of a squared, and this one is log base 7 of b to the 6, and log base 7 of c. And these are all plus signs, so I'm allowed to multiply these arguments. Log base 7 of a squared b to the 6c. That would be a way of writing 3 as 1. So if there's plus signs between them, I can multiply the arguments. Last section on this video is 60 through 69. These are ones you cannot do with your green sheet. Log base 5 of 44. I know 5 to the 2nd power is 25. I know 5 to the 3rd power is 125, so I know my answer is between 2 and 3. Just to give you a heads up, we can do what's called the change of base formula. If it's one we don't know, we can type in the log of 44. You take the log of the argument and divide it by the log of the base. And if I go to my calculator and type that in, log 44 divided by log 5, I get 2.351. And these are supposed to be rounded to the nearest thousandth. Yeah, I realize that there is a button on your calculator. You can hit math and scroll down till you get something that says log base, and you can put these in, log base 5 of 44 right away. Not all calculators that you will be allowed to use in college will have that. So you can use the change of base. That's what that's called, change of base. So please try that for 60 to 69.